Alright, this can be one of those situations where we talk a lot and you're like, what the heck are you talking about? You're going, Burkhart, I don't understand. And then I show you what is actually happening and you go, oh, that's super easy. Why'd you make it so hard by talking so much? So stay with me, and I promise you I'll get to the easy part. If you understand everything in between, we're okay. Alright, so today we're going to talk about converting degrees to radians, which is a really easy thing with a little bit of a tough explanation behind it, but it's so easy. You're going to love it when you get to this part on a quiz or a test, right? Our goal is to convert angle measurements between degrees and radians, right? Notice that an angle can be expressed in 2 units of measurement, a degree or a radian. What we're trying to do is getting kind of a hold on what a radian is. So a radian measurement is basically this, right? It's for a central angle theta that intercepts an arc of length s, right? On the circle with a radius r, the radian measurements of an angle is the ratio between s and r, between the arc length and the radius. So a radian measurement of a circle is really theta equals s is the number we use for it, right? And we got s over length of arc, right? Or length of the radius, right? So radian measurements are literally equal to arc length. Alright. Now, if we come down here, I want to point a few things. How many degrees are in a full circle? Well, let's talk about it. There are 360 degrees in a full circle. First question is answered. How do you find the circumference of a circle with a radius of r? Well, our circumference of a circle with a radius r is equal to 2 pi r. Alright? So, use this information to find the radians in a full circle, right? So, if the circumference is 2 pi r, right, we know that theta, right, is equal to arc length over r, right? And we realize the distance, the full way around it, our largest arc length can be 2 pi times the length of the radius, right? And the radius is also the length of the radius. So the number of radians in a full circle is 2 pi radians. Alright, I'm going to underline that. I'm going to say what it means. All the way around a circle is either 360 degrees if you're using degrees, or 2 pi if you're using radians. The measurement, full circle, is literally how many times the radius can fit around the circumference. We're literally using the radius as a unit of measurement that grows or shrinks with the circle as you go. Alright. So, therefore, let's talk about what that means converting them back and forth. 360 degrees is equal to 2 pi radians. And most of the time you just assume there's radians if you see a pi, right? So, alright, if 360 degrees equal to that, what if I do this? What if I find out how much 1 degree is? Well, to find out how much 1 degree is, I just divide both sides by 360. So if these two are equal, if I divide this by 360, I get 1 degree. And that's equal to, well, 2 pi divided by 60. Right? 2 pi divided by 360 gives me this. It equals, right? 1 degree is equal to, reduced by 2, pi over 180 degrees radians. Or sorry, pi over 180 radians. Alright? That's how 1 degree converts to radians. Alright? And the other way, right? If you do the converse of this, right? What if I make this side equal to 1? So 1 radian, I divide both sides by 2 pi, right? So 1 radian is equal to, well, divide both these by 2 pi, and I get 360 divided by 2 pi is equal to 1, right? That divided by 2 pi, that divided by 2 pi. And if I reduce this, right, 1 radian is equal to, well, if I reduce by 2, about 180 degree over pi. But you know what? These are actually conversions. Once you get something down to a unit, it is a conversion. But let's talk about it. So, converting to degrees to radians, right? If you're in degrees and you want to go to radians, you take the number of degrees, and you multiply by the conversion rate, which turns it into radians, right? Because a degree is the same as pi over 180 degree radians. And that will give you how many radians are in there. If you just look at it, right, you can see that to get from here to here, I divide by 180 and multiply by pi. Right? If I divide that by 180, multiply by pi, it'll turn into this. Converting from radian degrees, well, how would I turn this into this? How would I get from here to here? Well, let's look at it. If I have a radian, right, and I want to convert it to change 2 into 360, I multiply by 180, and I got to get rid of that pi, so I divide by pi. All right, and that will give me how many degrees? And literally that's it. I mean, honestly, you can do it right from here. To change degrees to radians, well, to change 360 to 2, I divide by 180, and then I have to multiply by pi. To change radians to degrees, right, to change 2 into 360, I have to multiply by 180, and get rid of that, I have to divide by pi. So I want you to see how easy this is. All right? I'm going to do the left side. I'm going to leave, well, you know what? I'm going to do the top 6. So 3 here and 3 here. I want you to do these down here. Without me, you don't need me. So degrees to radians. Well, to get from 1 to, I don't have pi. Radians need pi. And there's way too many degrees, so I divide by 180. All right? If I do that across, that's going to give me pi over 90, right? Actually, take that back. Pi over 9. 20 and 180 reduced to 9. We'll come over here and we'll convert the other way. This is obviously radians because pi's in it. So to convert to degrees, I got to multiply by 180 and divide by pi. Radians to degrees. We don't need that pi anymore. This reduces. Well, what does this reduce? If I divide 180 by 8, I'm going to get approximately, in fact exactly, 22.5 degrees. Coming down here, 315. Look, I'm in degrees. So to change to radians, I'm going to need a pi. I'm going to have to multiply by pi and divide by 180. If I do this, that's going to make 7/4 pi. All right, 7/4 pi. I don't mind if you put the pi up here or out to the side. I actually don't mind if you want to put this in your calculator. 315 divided by 180 and do second math, right? Enter. This guy right here, 4 pi thirds, is obviously radians. I'm changing to degrees. So to change to degrees, I need to get rid of that pi and multiply by 180. Well, this is kind of nice. That reduces pretty easy, right? That's 60. And what I get is 240 degrees as those pi's also cross off. All right. So I get a couple more. 600. Well, this is going to be bigger than 2 pi because it's more than once around the circle. So again, I'm in degrees. Radians need a pi. They don't need so many degrees. We divide by 180. This is going to be reduced, like 600. If it reduces to 180, you get 10/3 pi. Again, I don't mind you doing this in your calculator right here. To go from radians to degrees, once again, I have to get rid of pi and multiply by 180. All right. The pi's cancel out. What, 2 goes into 180, 90 times. And I get 90 times 90, which is, well, that's 90 times 9, 81 with a 0, 810 degrees. So I'm going to leave you guys down here. And again, there's your conversion rate. If you want to change to radians, multiply by pi, divide by 180. If you want to change to degrees, multiply by 180 and divide by pi. Look through this again. Try to think of how this makes sense to you. And I'll talk to you again soon.